Hey everyone, it's been a while since I joined a new company, so I've been solely dealing with like AI, GPU clusters and the likes, and it's been a very wonderful learning experience. But I could not just skip the new feature from the LR project. Uh, so far, I may be wrong, but then I think this might be the only open source 5G core project that has HA failover, sorry, and it's something very encouraging that we can have a project like this that has quality features such as this. There are other things that are also interesting in the LR core currently, like if you have been following the project, you have like the BGP feature inbuilt, right? That means you can advertise UEI pools directly to your network and the likes. They have done some work also on the Okudu project. That's the formerly SRS run project and a lot of stuff. So, but today I want to show you how, at least from my own opinion, how I was able to deploy the HA on Kubernetes. So, if we look at this, the HA is designed the Raft consensus algorithm. Somehow a little bit similar to how like your HCD works. Like you can only have like odd numbers, right? So it's either you go from 1, 3, 5 thereabout, right? But you can't, if you have 1, then that means you do not have HA at all. So at the minimum, what you have is like 3 nodes, right? So 3 nodes will tolerate 1 failure, thereabout 5 will tolerate 2. So that's what I'm saying. It's a bit similar. It's very similar to how your HCD quorum works also in Kubernetes. So the goal of the HA is that you will have a leader at one point in time, and then if that leader goes, then there will be a voting, then another node will become the leader. So the leader is where you have your when you want to add configuration changes at the global level, like subscribers and the radio networks and stuff like that. So that's the one that will do that you need to direct the configuration to, and then it's going to replicate it to the remaining members. So yeah, you can go through some of the the documentation here, and you see, and then there are a lot of various modes that you can actually use to test this. So if you have a commercial 5G radio, of course you can point it to the three LR core nodes, and if for some of you do not know that LR core is a self-contained 5G core, so that means it has the AMF, SMF, UPF, all the stuff 5G core in one. So this will represent like your 3 AMF, so to say, from the perspective of the 5G radio. So when the 5G radio starts up, it's going to have all this as what do you call it, as a list, and then some 5G. I believe I've not worked on the 5G commercial radios. Mostly I use simulators, so they will, if one node goes down, then they will be able to like load balance, right? So if you have a setup like this, then that means you don't need to change anything on the radio. If one of the node goes down, the 5G radio will simply fail over to any active one of the nodes. But you could also have it in such a way that this is still an HA cluster, but then you partition your network and you have multiple radios attaching to a specific node. So the major issue with this is that if one of these dies, then that means you have to go into the radio to do a manual switch over to what is to the remaining nodes that are there. So depending on your requirements, that might be that might be something uh, that might be you have to choose which method. But in most cases, I think this might be the ideal way. So this tells us about scaling the cluster and the likes. So the challenge here is in Kubernetes, right? So for you to create this kind of setup, first of all, one node has to be a hop. It is that node that will generate and mint tokens for the remaining nodes to be able to join the cluster. So you can do this manually. You can do this in several ways. But this gave me a bit of like an interesting challenge to see that, okay, how can we do this using Kubernetes, right? So that led me to like create, using some form of vibe coding also helped me with this, right? Because like vibe coding or using AI, it's not generally that you have the idea. You need to be able to do, I mean, to have a good idea, and then it helps your idea to, I mean, it quickens your idea, I mean, the stage from your ideation then to having something to run on, right? So that was why I was able to do this. And I have two kinds of chart for the LR course. So this chart here is the failover or the HA link. That's the cluster communication in between, because there is a need for them to be communicating the Raft consensus, right? So the communication between them, I'm actually using the N2 IP for that, because it's stable, it's static, right? We don't need to, I don't, because it will not really change, other than if you use the pod IP, then you have an issue if you use the pod IP, because pod IPs will always change when a pod is deleted, right? So this is kind of a bit of like a static implementation using IP. But then I decided to say, okay, why can't we just use like FQDN and then use the concept of like stateful sets. So with stateful sets you have a fixed way of ordering, right, as per the pod names and the like. So this brought about so what this Helm chart does a lot of things for you. For instance, it's able to provision. This is something that you can work on. So this is not this is just for test purposes. So what this means is that when the LR core is deployed, you don't need to manually go into the web UI interface and create the username and password and then generate the token, right? So this the bootstrap job does that for you. So the bootstrap job initializes the LR core. It does so like I said, so it creates the default admin user. Then it also creates the API tokens, which we'll see that UERANSIM also we use to detect which leader is up. Which of the nodes are the current that is the current leader. And then also it mints the join tokens and then it creates it as secrets, right? And also for our tests, it does the subscriber provisioning. So the fifth one is still, this is not really there, but subsequently we might have to, I might play around with that, but for now this is what we do. So what this does is that when you install this chart, it does a lot of things for you. Like I said, it brings up and it helps you with like your day one kind of configuration. And also I have also a leader watch deployment, and the reason for that, which we will see shortly, is that if you want to access I'm accessing the LR core via a NodePort. So by default, if you use the normal selector labels for the for the LR core. So that means that it means that it will load balance across the pods. And what that means is it will not always give you the real status of the subscriber, because the real status of the subscriber and the radio will be reflected in the on the leader, right? So it's the leader that will say that, okay, this subscriber is active or thereabout in our own case, right? So that's why this leader deployment will keep on watching. So if one of the LR core, if the leader is deleted or if the leader changes, what it does is that it's going to send a query to the API, and then it gets the current leader or the leader that has, when the voting has been done. So that particular leader, it will now deduce the pod name from it, and then from the pod name, it will now use the pod name as a selector label in your service. So that means that every time you use that service, so you can see from here, anytime you use this service, it will always give you the endpoint, the pod endpoint for this service will always be the leader. So that's also that's one of the things. So there are there are a lot of things. Of course, we are using Multus with whereabouts. The reason we are using whereabouts here is because it's a stateful set, and then the stateful set is 3 replicas. So with the 3 replicas, you cannot use static IP because it's not feasible to configure that. Or there are other ways you could do that, but then at least using whereabout in this scenario is sufficient to an extent, and it frees up from also having to add code these IPs. As you will see that even the way I did the UERANSIM is that when it's coming up, it actually queries also the API, right, for the LR core API to know which G-Node to know which LR core AMF is the active leader. Then he uses that then he uses some Kubernetes call to be able to get the Multus N2 IP address, and then that's what it's going to use to update its GNOB configuration, and then do the attachment. So before then, let's just quickly first of all install let's see how the LR core goes, and we'll see. So actually using a single node cluster, so just as a test, like I said. So once as that's going on, so we can quickly check the UERANSIM also. So the UERANSIM, just picking the one for Free5GC, it's already a container image, so I don't need to build another one. Then, like I said, this subscriber will be created by this as part of the provisioning. And also, so yeah, this is how we get to know how we communicate with the LR core API endpoint. So this is the token that is going to look for, because this token is a read-only token. It's not, I believe it doesn't have like the admin privileges. And then also you have the Multus interfaces, and then some of the things, some of the other stuff here. So if you look at this, both the UE and the Gnode B, they have 2 containers. So like I said, the init container is just to be able to automate part of the the configuration, and then the Gnode B container is where you actually have the Gnode B process. But then we have this container that actually does the leader watch, right? So like I said, once the leader changes, UERANSIM will automatically reconfigure itself. So that's why you have all this here. And the UE also does that also. It also detects so this is just the way UERANSIM, it's just to give a clean way of demoing this, right? So normally commercial UEs or your normal UA handset, you may not need to do this step, but this is just a way to make the lab to be a bit fun also, and also to simulate how it will be. So let's see, we already have it running. So let's see, if we get pod, we'll see that we have three. Like I said, we have 3 replicas. So in HA, we have the leader watch. So the leader watch, like I said, is the one that will update the service. So if we see here that you have 2 services, like I mentioned, so this leader watch will always update this service to point to the actual LR leader. So that's that. We can quickly check some of the logs to see. Let's see the provisioning. So this is when it was still coming up, right? So that's why the leaders were not no leader was already detected, right? But then you now see that it says leader changed, no ID one, because it's just starting, right? So you can now see that the first leader is actually the LR01. So this is the one that actually that will do the node mint, the join token and the likes. So if we see some of the logs are a little bit much, but let's keep that for now. The UERANSIM would be like the better stuff, right? So let's first of all see the normal service. This is where you see exactly what I'm trying to say. So since it's a NodePort, no, this is actually where it's running. So I'm only using that as a place where I built the Helm chart. So if we copy this and then we go back here, so we see that is it this? No. So this is port 3050. Okay, I already have it here. So the default username, like I mentioned there, is if we come here, you see the default username, and then password is change me. So yeah, you can actually see that we already have 1 subscriber, because so this is the UE, but it's not registered because the UERANSIM is not running currently. So the radio there won't be any radio because we've not done the UERANSIM. Then if we go to the cluster, we'll see that this is how the cluster runs. So subsequently, you see there are 2 things to take note here. So there is a leader, and then it says this node. So that means this is the pod that this UI is actually listening on. This is the pod, and when we say this pod, you can see this is node ID 1. This node ID 1 maps to LR0. That's the first replica of the stateful set, right? So what this means is, and like I said, I'm picking this service from the leader core. So that means that's why it's static. It's not changing. It always show that this is the leader node, and that this is also the node that this API is being accessed. So if I change it to like the other normal service, and then the normal service is the round robin one that just goes around. So here you can see now that it's showing that this is the leader, but you see that this node keeps changing. It's because Kubernetes is doing this UI is reloading at the back end, right? And then it's choosing another pod. So once it moves to another pod, this node label will change. So for instance, now we'll see that we don't have this node that we are currently on is not the leader. So, but if we use the same, but the one that has the 3, so this is the one that has, this is the service that maps to the leader port. So you can see that this does not change. So the key point here, we'll see if we now install the UERANSIM. So let's install the UERANSIM, and then let's go back to the KNIS, and let's so this is initiating the Gnode B is also coming up. So yeah, we can see the logs of the UE. All right, so we can see that the UE is up, and the PDU is and you can actually see that the sidecar also comes up, like I said. So it's able to know that, okay, this is the leader node, that's the LR cause 0. So if we go back to let's go back to the one that does not tie the leader node and the API node that is serving this web UI. So if you go to subscribers, you will see that it's showing deregistered because the current node we are on now is not the leader, right? So it's not the one that we are connected to for the subscriber. But if we go to this and we go to subscriber, we actually see it's showing that it's registered. So that's one thing to be aware of if you always want to connect to the leader node all the time, right? So it's something that you have to think about, that for you to have a good reference of to get where the status is, you need to always connect to the LR core node that's the leader in this case. And take note, you can still like we showed, that you can actually have multiple nodes or different 5G nodes connected to separate nodes here, right? So for instance, if it's connected to this node, of course you will need to remodify your you need to modify the way you do your services, right? So as to be able to know, to get an accurate status of what the subscribers are connected. So that's if you come to the radio, of course you see that the radio is there, the UERANSIM. But if you come to the other one and you go to the radios, you see that the radio is showing not found. It's because of just what I just explained. So now this is the time to test the failover, right? So what better way to test the failover than to just delete one of the pods? So we know that LR 0 is the leader, and immediately we do this, and then we come back here, we see that this is showing LD, and immediately we see that it's LD. It's on LD. We can now see that take note of the IP. We can see that 188 is now the leader. Before it was 164. So that means node 2 is now the leader. But then because we deleted the pod, right, the stateful set will recreate the pod. You can now see that the pod has recovered and the cluster is now back to being healthy. So if we come back here, we'll see that even if we refresh, no matter how many times we refresh, you can now see that the leader now is on node 2. So you can see here that it's now 188. So that's just to show you how the failover works. And even if you still go back here, you still see that our radio or our UE is still connected, even though there was a change in the leadership, and then your UERANSIM is still also connected. So, but if we go to the UERANSIM logs, for instance, we'll see that this is the first setup, right? This is the first setup when we first of all installed the GNodeB. So when the leader changed, you can now see that it's saying some failures and then could not find a suitable AMF, blah blah blah. Then you can see now that we have a detection here. So the detection is saying that, oh, the leader has changed from this, which is LR core 0 to LR core 1. So these are the N2 IP addresses. So one thing to take note is that this leader watch is actually the sidecar. What it's just doing is it's sharing a configuration file in between the two of them, right? So once this leader core populates that config file, then there is a wrapper around the UERANSIM that will detect that, oh, there is a change in the configuration, and then it will restart the GNodeB process. So you can now see that it says it's restarting with a new leader, right? So before it was .10, now it is .11, and then it goes ahead to do the reconnection, and then the UE also does the new PDU connection. So if you see the UE also, you can see that twice it actually did the PDU connection, right? So it's also first of all, it will also check if the leader has changed, and then before it will also do a readiness check from the GNodeB to make sure that, okay, the GNodeB also is up and running before it tries to attempt to connect. So this is kind of the automation that I actually did, and I wanted to show the community on how to do that. And this, if you want, you can go through the charts and see some of the scripts that was used to implement this. So this has been an interesting learning experience for me also, and I also want to appreciate the main maintainer of the LR core project. He took time out to make sure that the FQDN feature is actually working. So I encountered some bugs with when I was trying to use the FQDN instead of the IP address, and he was gracious enough to quickly address those bugs. And with the version 1.11.0, which is what I also used to test this, it looks stable. So that's that for now. I hope you find this interesting as I have, and I'll see you in the next. Thank you.